Amidst the vast expanse of space, a collection of over 30 galaxies encircles the Milky Way, forming what astronomers term the local group. Yet, the title of the largest galaxy eludes our home. A celestial elder sibling, the Andromeda Galaxy, claims that honor. While its proximity offers a sense of closeness, the reality remains that Andromeda is distant by a staggering 2.5 million light-years, a cosmic span much like that of our own Milky Way. Characterized by its elegant spiral structure, Andromeda stands as an older kin with several shared features. However, in sheer size, it dwarfs us. A beacon of brilliance, Andromeda's luminance renders it the most remote discernible object visible to the unaided eye. This giant harbors a staggering multitude of stars, exceeding the trillion, whereas our Milky Way holds a count ranging between 200 to 400 billion. Spanning more than 200,000 light-years in diameter, Andromeda's width is approximately twice that of our galaxy. The intriguing question persists: how did this colossal entity evolve to such proportions? What mysteries lie within its brilliantly illuminated core? Both the Milky Way and Andromeda likely initiated their cosmic journeys around the universe's dawn, 13.5 billion years past. Over time, these galactic siblings expanded, ingesting and interacting with smaller counterparts. An inevitable fate awaits: a cosmic collision between Andromeda and our Milky Way. Though projected to occur in roughly 4 billion years, simulations predict a 2 billion-year union period. The merger shall alter our familiar spiral form into a singular mass termed an elliptical galaxy. An artist's rendering envisages the sky's appearance prior to this momentous fusion. Another commonality shared by the two giants is their central bulge, housing radiant stars. Concealed at their hearts resides a gravitational behemoth, a supermassive black hole. These enigmatic voids, astoundingly massive, tipping scales at millions to billions of solar masses, stir astronomical curiosity. The precise mechanisms behind their colossal growth remain elusive, potentially tied to their positions at their host galaxy's nucleus. Recently, a groundbreaking image unveiled the supermassive black hole at the Milky Way's core, named Sagittarius A*, capturing it in a visual grasp for the first time. A spectacle analogous to this presents Andromeda's central bulge, engulfing its obscured black hole. In 1993, astronomers uncovered two luminous clusters encircling Andromeda's core, one blue, the other red. A decade later, insights emerged. The blue cluster, an assembly of youthful, scorching stars around the supermassive black hole, echoes a feature inherent to the Milky Way's core. Conversely, the red cluster within Andromeda's core reveals an asymmetrical elliptical disk housing older stars, enveloping the blue cluster and the central black hole. This red stellar disk finds no counterpart in our Milky Way, spurring investigations into the cosmic events sculpting Andromeda's past, yielding its peculiar attributes. Recent revelations trace a colossal cosmic collision as the catalyst. Andromeda's central supermassive black hole, around 100 million solar masses, surpasses its birth size, amassing mass across its existence by devouring neighboring objects, including fellow black holes. This insatiable hunger potentially sculpted the enigmatic lopsided disk of ancient stars ensconced in Andromeda's core. The chronicle unfolds thus: over 1 billion years past, a colliding galaxy commingles with Andromeda. This interloper's black hole gravitates towards its larger counterpart, triggering an intricate orbital dance. Matter spirals toward these black holes, coalescing into stars orbiting a few light-years distant. This birth of stars forms a ring encircling the black holes. Their ultimate merger resonates in a monumental release of gravitational waves. Should a substantial asymmetry exist between merging black holes, the resulting burst may exhibit uneven radiation, imparting directional momentum. This asymmetrical release propels the fresh black hole at considerable speeds, potentially reaching 200 kilometers/second, 125 miles/second. Orbiting stars experience similar momentum, disturbing their circular paths, reshaping them into elliptical orbits. Consequently, the lopsided appearance of Andromeda's core is explicable. A congregation of stars slows as they move away from the black hole. Notably, the azure clusters denote younger stars, implying diverse origins through various scenarios. This narrative illuminates merely one probable sequence of events shaping Andromeda's current state. As technology advances, deeper exploration of nearby galaxies' cores promises further insight into the eons-long evolution of celestial entities like Andromeda and our own Milky Way. This voyage into Andromeda's heart offers a glimpse into cosmic history. If this exploration captivated you, consider showing your appreciation by tapping the like button. If you're yet to subscribe, your support in doing so is immensely valued. Thank you for accompanying this journey, and until next time, take care.